Hi guys, and welcome to this video from the P-Way engineer on the two basic principles behind the design of railway signalling. As with the rest of the railway and wider society, railway signalling has evolved over the years from a simple start to the complex systems in place now. If you find this video useful, please do subscribe to the channel. There are videos covering a wide range of railway engineering topics that I'm sure you'll find interesting. Let's start with our first principle, safe spacing of trains. Trains are a guided transport system. The wheels run on fixed rails, on fixed routes. This means that they are unable to swerve or avoid collisions like cars. Given that trains can also run at high speeds, something that makes rail travel efficient, keeping them apart to avoid collisions is key. Collisions on the railway can happen in two main ways, either head-on or with one train hitting the other from the rear. This need to keep trains a safe distance apart led to a number of different ways to ensure that only one train is present in an area of track at a time. Early systems were based on drivers proceeding at speeds slow enough so that they could stop in time from any obstruction further up the line, in the same way that we drive cars on the road. This has obvious drawbacks. It's dependent on local weather conditions as well as the distance the driver can see. The low speeds required are also not efficient for the longer train journeys. Another option was setting trains off at set time intervals. This has obvious disadvantage that if anything happens to the train, such as it breaks down or cannot achieve the stated speed, the following train will catch up to it, leading to a collision. You can see that with these options, you could run a railway in a way that trains can run up and down the track, but you can't really run a service like we expect today with high frequencies of trains running at high speeds. The system used to maintain the safe spacing of trains in its most basic form is known as block signalling. The track is split into blocks or sections within which only one train can be present at a time. Signals are used to indicate to the drivers if the block ahead is clear or occupied by another train. While this used to be done by signalmen observing the start and end of each block and then changing the signals as required, now train detection systems are used. You may have heard of track circuits or axle counters, both of which are types of train detection. Our second principle is the safe routing of trains. Unless we wanted a simple train line that went from point A to point B on a single line, like a shuttle bus, trains need to be able to change routes at junctions. This involves moving parts of track, called points. This brings in the risk of trains being incorrectly routed, in the worst case scenario, into a head-on collision with another train, as well as the risk of routes being changed underneath or in front of an approaching train. So how do we manage this? The answer is interlocking. Interlocking is a logic system that only lets things happen when certain conditions are met. It's worth saying that interlocking is also used for train detection as well. It stops two trains being in the same block at a time. Signalling systems are integrated, so there is a large amount of interdependency, and it's hard to see sometimes where different sets of interlocking start and end. When it comes to routing, interlocking ensures that the points are swung and locked in the correct way, that the track ahead is clear, and that no other conflicting moves on other sets of points have been set that will cause a collision with another train. Ensuring the points are locked prevents them from moving under the train, while changing the route at the last minute as the train approaches. While interlocking is a simple concept, once the track layouts get complicated, the design of the interlocking also becomes increasingly complex, with the number of inputs becoming greater. Both of these principles ensure that trains travel on the track safely. Although simple in theory, countless examples of railway disasters throughout history show what happens when systems fail and these principles are not met. The Clapham Junction incident in 1988 that claimed the lives of 35 people while injuring 484 from a rear-end collision shows what happens when the space between trains is not maintained. I hope you found this video interesting and it gives you a small insight into the two basic principles that underpin signalling system design as an introduction. Please do give the channel a subscribe and a like.